So now we've trained our models. We've made sure that they perform well. Now it's about taking these models and deploying them on the edge. So what we need to do is navigate to our H5 file. So that's this one that we trained, and we just open it as we did before. So now we go to the code gen. This is essentially the tab that gives us the options to target different kinds of architectures and convert it in different ways. So you can see here from this list, you have different options. Let's first go through the C99 option. So you can choose different naming conventions, output directory, and things like that. You can always click on the question marks to learn more about what they do. But essentially, we're just going to use the default options and then hit generate code. So with that, the model is converted to the edge. What we did was we created this gen output directory that we see here. And now we have these two files that we can take and put into our firmware project and compile with the rest of the project. So let's take a look at these files. First, we'll look at the header file. If you scroll down to the bottom of this header file, you will see the APIs. So these are the functions that are included in this model. First, you have the initialization function, which you use to initialize the model and to reset the buffers. Then you have the enqueue function. This enqueue function is the function that takes the data in and buffers all of the data. Then you have the dequeue function. This dequeue function is the function that runs the data through the model. So when this returns a success, which is 0, then that means that you have a valid prediction in the output. And then you have different defines that are available to help you control your model. So you have your data out count. This determines the size of this data out buffer, and your data in count, which determines the size of your data in buffer. You also have a lot of information to help you manage your different models. So we build in the statistics from the model that to help you track the different models. And we also have some information about the model architecture, the pre-processing, the different labels that are available in this model or the different classes, and then the memory footprint. So you can see the RAM values and the flash value here. So in this case, you add up these two buffers, and this is about 19 kilobytes of RAM. And then this one tells you the flash. So it's 153 kilobytes of flash. So now we've looked at the C99 code, but let's target a specific architecture. So we're going to look at the Infineon PSoC devices and target the PSoC 6. So here you essentially go about it in the same way. You pick the directory and the file prefix. But now we have some optimization options. So we can use the preprocessor acceleration. And here, let's use the floating point unit. And then we can also, we have the possibility of enabling the quantization. Let's do that. And to enable the quantization, you need to add a representative data set. So we're going to add our project file, which will tell the platform which data set to use to verify the quantization. And we do the exact same thing as we did before. So we just hit generate code and let the platform convert the model and perform the quantization. And because we've selected quantization, it will take a bit of time while it's running through all of the data and doing the fine-tuning. You can always click on show progress to learn more about the progress of the quantization. While the quantization is running, we can also take a look at other parts of the model conversion. So We also have support for the PSOC Edge and the U55, which will allow the model to run on the neural network accelerator, which gives you even better performance. We also have support for other kinds of Infineon boards, for example, the RX and Trevio and XMC. So now the model conversion and quantization are done. The first thing we get is a report which tells us how much memory the new model uses. You can see that before, when it was in floats, it was using 160 kilobytes of memory, and now it's using 54. So you can see it's a lot less. And in terms of scratch memory, it's also less. We also get some information about the cycle count. Now we can see that we generated this Infineon folder, and in that we get different kinds of files and information, reports, logs, etc. But in the end, all you need to run this on your device is just to take this model.c and model.h files. So everything is included in that. So now we've deployed our model on the AI evaluation kit, and we're getting some prints on the terminal. And you can see here that it's predicting unlabeled with 99.6% confidence. This is this value here. And the probability that it's a siren is essentially 0, which is actually what's expected because I'm talking and it's not actually a siren. Now we will actually play a siren that's coming out from the speaker located here and going into the board. So you can see that when the siren was playing, the confidence level that it's a siren went up to almost 100%. And then as soon as the siren stopped playing, then it went back to 0. And I will play it again just to demonstrate. So this is how you can actually test your model in real time on device. And you can see that just as easy as replacing the .c and .h files in the example code, you have a completely new model running on the device. So now we've trained our model, we've converted it to the edge. Now we can actually build a project around it. So what we have to do is just go to ModusToolbox, and then we're going to create a new project. So what we want to do is to select the right board. I'm going to be using the AI evaluation kit, so I will select that. And at this point, I'm going to use a code example that I have available locally. But otherwise, you would be able to find the Imagimob code examples under this machine learning category. So I'm going to navigate to the right space. I'm going to run this project, so the Imagimob deployment code example. And then we'll just let that create the code example. So first I have to name it. Let's call it and then hit enter, and then click create. So you can access this deploy code example from our documentation. If you just go there, then you can download it, and it's an open source Git repo. So now the project is loaded into ModusToolbox. So we can see that in the models folder, we have the .c and the .h files. This is our model. And then in the main.c, we have all the code interacting with the model. So if we navigate to the main.c file, so in the main.c file, we can see the different properties of the microphone in order to get it prepared for the input. We also see in the beginning of the main function, we will initialize the model. And then whenever we get a new sample from the microphone, we do a normalization and then we pass it to the enqueue function. And then we check if the model is returning a classification, in which case it will return a success. And in this, we will do some manipulation of the output. So we get the label scores, and then we check if it's which is the biggest one. So we're essentially performing an argmax and then printing that out. So what we're going to do is this example has, if we look at the model.h file, it has the up and down keyword spotting example, but we want to replace this with our own model that we train. So you can check that here. So what we're going to do is move to the Imagimob Studio and navigate to the right folder. So we're just going to open that up into our Explorer. And then take these model.c and model.h files. So this is our PSOC6 quantized model. And then we're going to paste it in here and overwrite the old model. And then with that, we just build and compile the model and deploy it on the board.